Now let's see an application of the Bernoulli equation. In this application, we will talk about the Venturi tube. This Venturi tube is used to measure the velocity of the flow of the fluid in a tube. The principle of this Venturi tube is rely on the Bernoulli equation. Okay. If we write down the Bernoulli equation again, we have that P1 plus 1/2 of rho V1 square plus rho G Y1 equal to the P2 plus 1/2 of rho V2 square plus rho G Y2. Okay. And if the flow is in the same level, that is, if we have that y1 is equal to y2, so the Bernoulli equation can be rewritten as the P1 plus 1/2 of rho V1 square equal to the P2 plus 1/2 of rho V2 square. Okay, so you can see that if V1 is larger than V2, we will have that P1 is smaller than P2. Okay, or if we have that if V1 is smaller than V2, we have that P1 is larger than P2. Okay, it means that if we consider the flow in the tube at the same level, the pressure is large when the velocity is low, and the pressure is low when the velocity is large. So we can compare the velocity of the fluid by comparing the pressure. Okay, we can compare the velocity in 2 points by comparing the pressure at that 2 points. So in principle, if we measure the pressure difference between 2 points in the tube of flow, for example, if we measure the pressure here, and if we measure the pressure here, and we can calculate the pressure difference between these 2 points, and from the Bernoulli equation we can calculate the velocity difference. Okay, velocity difference between these 2 points. Okay, so it means that we can measure the velocity difference by measuring the pressure difference. in the real equipment, as in this figure, you can see that in the venturi tube, they have the tube here, in the middle, you have the tube with the smaller diameter, and in this tube, they connect with the small tube like this, and in the middle, they connect with the small tube too. And in this small tube, they fill with the maybe the alcohol with the color like here. So when you flow the fluid into this tube, you can see that since the flow is come from the tube which is larger diameter or larger cross-sectional area to the region with a smaller cross-sectional area, the velocity will change due to the continuity equation. Okay, A1 V1 is equal to the A2 V2. Okay, and once you have the velocity difference, you will have the pressure difference also. So the pressure in this tube is different from the pressure in this tube, and the velocity here is larger. It means that the pressure in this tube is smaller, and since the pressure in this tube is smaller, the pressure in this tube is larger, and the fluid in this tube, or maybe the air in this tube, will push the liquid, this lead liquid, up. So you will see the difference of the level of the lead fluid or lead liquid. And if you measure the difference here, if you measure the delta Y here, you can calculate the pressure difference. The pressure difference must be equal to the rho G delta Y. This rho is the rho of the lead liquid. Okay, so in principle you can measure the pressure difference. And once you can measure the pressure difference, you can measure the velocity difference. But if we want to know the velocity here, we can do that if we know the cross-sectional area of this tube. And if we call this as a A1, this area is a A1 and this is a V1. And if we know the cross-sectional area here, we call it the A2, and the velocity of the flow here is V2. So in principle we can calculate the difference between V1 and V2. Okay, but we can calculate the absolute value. For example, the absolute value of V1 here, if we know A1 and A2. Okay, we can do this by using first the continuity equation. Okay, and second we use the Bernoulli equation, P1 plus 1/2 of rho G V1 square is equal to the P2 plus 1/2 of rho G V2 square. Here we may not know the P1 and P2, but we know the difference between P1 and P2. Okay, we have that P1 minus P2 is equal to the 1/2 of rho V2 square minus V1 square, and this P1 minus P2 is the pressure difference. Okay, and this is the second equation. So we know everything here. We know the P1 minus P2. In principle, we know the law of the fluid. So what we don't know, okay, we know if we build this venturi tube, we know the cross-sectional area A1 and A2. Okay, so what we don't know now is the V1 and V2. We have two variable with two equations. So in principle, we can solve this. Be careful here, low here is the density of the fluid flow in the tube. This is not this low. Okay, I may write this more explicitly. I will write it as a low R, okay, which is the low of the red fluid in this figure. Okay, so you have two variables, you have two equations. In principle, you can solve this equation, and the final result is V1 is equal to the A2 times the square root of 2 delta P over rho A1 square minus A2 square. Okay, so it means that you can measure the velocity in this tube if you flow it through the venturi tube from this equation.